Okay, so let's look at what we do if we think about we should have signed things, where that takes us. So we want to verifiably define the steps of the software supply chain, verifiably define the authors, and guarantee that everything happens. So our goal here isn't just to produce a document to say, here's what we think should have happened, but to have a way to gain some level of assurance that this is what actually did happen. Does that make sense? And have that be machine verified, not require humans. So the way this happens is in Toto, you have something called a layout. And a layout is kind of like what the SBOM is to some degree. It describes these are the different things I have in my environment. Oh, I have a VCS, I have a build system, I have packaging, I have testing of different types. It also describes that there are different like functionaries, there are different parties that have keys that do these things. So for instance, Bob is the developer who's always the one responsible for tagging the release that's supposed to come out. And Carol went and generated a key that lives on our build system and that is automatically used by the build system to sign things that it does. Does that make sense to everybody? Okay. And then you have things that go in and out of these different steps. So for instance, you have your signed get tag here, and then this is the thing that's supposed to go in to the build system, and then the build system comes out and produces a binary that's supposed to go into what's packaged. And then you link all of this together with artifact rules. So basically your layout says that, hey, testing has to be done over the signed tag get release, and then that signed tag get release is the thing that has to be built, and the thing that comes out of that compiler is the thing that has to be packaged. And if all of those things are true in this layout, then this is a valid version of this software. Okay? Everybody kind of get the idea here? Good. Okay. And then you sign this by a project owner, which lets you do things like revoke and change this over time. So if you decide that you don't just have one silly step here that just does linting, but you're actually doing fuzzing as well, and you add a step for fuzzing, then you would add that into your layout. And then next time you generate your software, you would expect that there would be links for your fuzzing as well as links for the other parts that we have here. All right, and then as you actually do the steps, you do something very simple. So when you go to do your testing step here, you just would do your normal command, only you'd preface it with a little prefix that looks something like this, like in toto run. And what this will do is this will automatically generate a signed piece of information that contains like what went in, what came out, and a signature from this party that says exactly what's happening in the system. In this example I have here, each of these 4 steps has a party go through, generate a piece of link metadata, and then with these link metadata and the layout and the thing it's over, you can then go and check this and cryptographically verify on the end user that everything happened the way it's supposed to happen, right? And there's a few really interesting things we found. And by the way, usually, you may think, well, this might be a bunch of files. Usually just stick it in one file and distribute to the end user. Just like if you look at what a package or, when you package things now, you typically plop a bunch of stuff together in a package. But one kind of interesting thing about this is we accidentally, by doing this, protected against attacks we weren't trying to protect against. So I can give you an example of one of these. When you go and you unpack packages on a system, there's a type of attack that Android and Fedora and a few others had problems with that dealt with if you have duplicate copies of something with the same file name inside of an archive. They were doing a check over one copy, but then they were using the other copy. So for instance, when you unpack the first one, you would say, okay, this is the one I'm going to check like the hash of when I hash the package, but you would actually replace it with the second copy in there. And so for a while, and actually my former student found and fixed this in Google about a month after he finished working for me. He went there to work on their package security team for Android, and found that that he could have compromised and caused big problems with basically all Android packages because of this. So in Toto, you just naturally protect against this because it's natural to say, when I unpack the things, they should be the same things that came in, right? It's just like, of course. And so in Toto automatically flags us and says, hey, there's something wrong here, even though that wasn't a bug we were ever trying to prevent. We hadn't thought of that. We hadn't thought of that when we were writing our layouts and things and testing it. So within Toto, you end up writing this layout, and it's actually very simple to go and generate this link metadata. In fact, I had a quick chat with Brandon after his part of his keynote earlier today, and he's already generating a Horizon build system link metadata and stuff like that. So hopefully, like a soon future release of this will have all of this all built in. But it's actually surprisingly easy to integrate. So you have your layout, you have these other things, you have this final product, and everything is checked and verified that the process you said should happen is what happened. Okay, and that's what Intoto is able to do for you. If you don't use Intoto, even if you use good solutions at different individual places, you're still going to run into quite a few problems because hackers can get into your system in lots of different places. Okay, it's been integrated lots and lots and lots of different places. It's being used by thousands of companies and is really being pushed by Microsoft and Google as potentially like a industry-wide standard for some parts of this. So we're also continuing to really aggressively try to push this forward because not because we want to sort of win, but because the other things we've seen in this space have had pretty obvious flaws. And we don't want to sit around and, even though it's good for me to write papers for the next 20 years about how bad all these other things are, I'd rather just have them not impact users' lives. Okay, so for software supply chains, use Intoto. Securing the whole software supply chain is important. This is the first tool to secure the whole software supply chain. I think we released the first version of this in 2017 publicly, or at least I think we had our first adoption release around that time. And one thing we did when we did this is we spent a lot of time working together with my team, red teaming different, very subtly different designs for this. And what that's meant is we know where a lot of the problems are if you don't do things in quite the right way. So what we have has been adopted in a lot of the other like popular things you might know of, like Salsa, the thing underlying GitHub, and SigStore, in part because in many cases, engineers from those teams would do a design and we'd say, wait a minute, that was a design we thought of a while ago and we realized there was this problem with it. So we reach out to them and say, hey, you have this problem if you do it this way. And then they say, oh, yeah, that's right. Okay, we're going to do this instead. And then we'd say, oh, yeah, well, if you do that one, you're going to have this problem. And then after doing that usually 2 or 3 times, they say, okay, well, what should we do? And then we're like, you should use Intoto. So that's why we're kind of underlying a lot of the other technologies out there in the space. It's a Linux Foundation project. It's free, open source, open community. Encourage you to experiment with it. So to kind of wrap up the last little bit of my talk here, I'm going to do rapid fire on a few important topics that don't neatly fit into exactly software updates with tough Optane or software supply chain within Toto. So what should we do with our dependencies? Question number 1. Okay, so avoid big dependency chains. So NPM is a really, like the whole Node.js NPM environment is really terrible for this, where Discord, which many of you have probably used, has about 20,000 packages and about 40,000 developers have contributed a line of code that's in Discord. That is insane, right? Okay? So avoid ecosystems like that if you at all can, to be bluntly honest. You need to validate your dependencies the same way you sort of validate and trust your own code. So looking at things like, is it maintained, is it well engineered, has it been audited, are they actually producing releases in a secure way? Because a trend has been that people will take over either developer accounts or even just kind of buy a project from a developer, sometimes by contributing for a while and then taking over or doing other things, and then use that to distribute malware or put backdoors in systems. You also do absolutely need to update your dependencies frequently and be worried and trying to do this, because once again, like, old code is very likely to be vulnerable code in many cases. You can look to see, am I even using this code path or things like that, which I strongly encourage you to do, but don't have old dependencies around, or you're going to end up with all kinds of like log4j, whatever, issues. And you need to recurse. So if your dependencies have dependencies, you need to worry about them as well.